All right, let's dive right into this. Today, we are tackling one of the most famously mind-bending objects out there, the Klein bottle. It's that shape that always pops up as the go-to example of some bizarre, higher dimensional thinking. But what if the way we usually talk about it is just fundamentally wrong? What if the real confusion isn't in the bottle, but in the words we use to describe it? And that quote right there from our source log just perfectly captures the feeling, doesn't it? You look at one of those glass Klein bottles and someone tells you it has only one side, no inside, no outside, but your own eyes are telling you something completely different. You see a hole, you see where it intersects itself, and it just feels, well, it feels wrong. It breaks your brain. Trust me, you are definitely not alone in feeling that way. So this brings us to the central mystery of this famous object. On one hand, it's celebrated as this seamless, one-sided surface, a perfect mathematical idea. And yet, every single physical model you can actually hold in your hand has a really obvious rule-breaking flaw. That hole where the neck has to pass through the side. Okay, so here's where the paradox really sinks in. The Klein bottle is what's called a non-orientable surface. What does that mean? Well, in theory, you could start painting the outside, keep going, and you'd eventually find yourself painting the inside without ever lifting your brush or crossing an edge. But to actually make that happen in our three-dimensional space, the model has to intersect itself. And that self-intersection is really the heart of the problem. Is it just a necessary compromise for us to see it in our 3D world, or does it mean the whole concept is just flawed in reality? The person in our source log got totally stuck on this exact point. They were trying to make sense of this apparent flaw by comparing the bottle to simpler, everyday objects, just looking for a representation that didn't feel so, well, broken. And this slide shows a really fascinating thought process. So on the left, you've got your standard Klein bottle with that weird, kind of artificial-looking intersection. Then on the right, you have a simple bowl. The thinking here was, look, if the goal is to have a surface where you can move from inside to outside continuously, doesn't a bowl with a smooth, rounded lip do that perfectly well without having to punch a hole through itself? And that just illustrates the frustration so brilliantly, If the 3D model of the Klein bottle fails because it needs a hole, while a simple bowl can do something similar without failing, why are we so obsessed with the bottle? It kind of feels like we're celebrating a failure. And this is exactly where the standard explanation usually comes rushing in. And that standard explanation, it's often where we make a huge mistake in our thinking. It's an easy answer that sounds really smart, but it just muddies the water and, honestly, hides the true beauty of the object. I'm sure you've heard this before. Oh, the hole is there because our puny three-dimensional brains can't possibly comprehend the bottle's true four-dimensional nature. The idea is that the intersection isn't really there. It just looks that way from our limited perspective. It's a neat trick for sure, but as our source log points out, what does four-dimensional actually mean in this context? And this is the light bulb moment. This is the big breakthrough. See, mathematics can describe an object using a million different variables or axes, but that's just data. That is fundamentally not the same thing as a fourth spatial dimension or the dimension of time. And mixing those two ideas up, that's the root of all the confusion. So, to clear all of this up, we need a better framework. We need to stop throwing the word dimension around so loosely and start defining our terms with a bit more precision. So, let's build that new framework right now. Okay, this is probably the most important distinction we're going to make today, so let's really let it sink in. A dimension is a fundamental mode of existence, like the physical space we live in. An axis, on the other hand, is just a coordinate, a piece of data we use to describe something. Think about a car. We can describe it by its length, width, and height. That's three spatial axes. We can also add its color as a fourth descriptive axis. But does that make the car a four-dimensional object living in some higher reality? No, of course not. It's just a 3D object with four descriptive parameters. Getting that difference is everything. So let's use this new framework to build a clearer picture. We can think of three totally distinct dimensions here. Let's walk through them. First, you've got the 2D conceptual dimension. This is the realm of pure information, of math and ideas. Think of a blueprint for a house or a formula. It exists perfectly on paper, not tied to any single point of view. Then, in the middle, we have the 3D rendered dimension. This is our world, the familiar physical spatial world, where we experience things, where that blueprint becomes an actual house. And finally, there's the 4D time dimension, which is the process of change itself. The Klein bottle's true, perfect home, it's in that first category. It is a 2D conceptual idea. And with this framework, we can now translate all that old, confusing language. So when someone says the Klein bottle is a 4D object, what we now understand they really mean is that it's a 2D conceptual object that's just very difficult to render accurately in 3D. When they say it passes through itself in the fourth dimension, what they mean is its 3D model has to self-intersect, but the pure 2D mathematical concept is perfectly seamless. See the difference? So let's go back to our famous flawed bottle one last time, but now with our new, much sharper understanding. Let's put all the pieces together. So here it is, the corrected understanding. The Klein bottle isn't a failure. It is not some flawed visitor from a higher dimension. No, it is a perfect idea in the 2D conceptual realm, an object described by a set of mathematical parameters. The flaw isn't in the object at all. It's just an artifact, a side effect of trying to squash that perfect conceptual idea into our 3D rendered space. The flaw is in the shadow, not the thing that's casting it. And this brings us right back to that moment of resolution from our source log. Once the speaker reframed the problem, the object went from being this confusing failure to something way more interesting. The magic isn't that it's from another dimension. The magic is that we can take a pure 2D informational concept and create a physical shadow of it in our world, no matter how imperfectly. That's what's cool. So let's all make a pact to be more precise, yeah? Instead of saying the Klein bottle is a 4D object, let's say the Klein bottle is a fascinating 2D concept. Instead of saying it needs a fourth dimension, let's just say it can't be represented perfectly in 3D space. This isn't just about being a pedant, it's about actually achieving a genuine understanding of what's going on. And this really brings us to our final thought. The Klein bottle is such a perfect example of how lazy language can create mysteries where none actually exist. It really makes you wonder, doesn't it? What other complex ideas, in science, in philosophy, maybe even in our daily lives, do we fail to grasp simply because we're confusing our terms and mistaking the shadow for the real thing?